Okay, we're going to go from standard to vertex form by what's called completing the square. It's one of the processes and is the most popular one taught in high school math. First, we have to define our standard and vertex form, and we're talking about quadratics. So for our standard form, it's usually written like this: y is equal to ax plus, or ax squared plus b at x plus c. Okay, this is our standard form. Standard. And we want to convert it to vertex form, which is, vertex is a really helpful form because it's pretty easy to graph. It tells you where the vertex is. And the process is called completing the square. We'll call it CTS, completing the square. Okay. And we're going to go through the steps. So each step is really important. And the very first step is what we want is we want to create a 1 value, a 1 coefficient in front of the sx squared, which means whatever the a value is, we're going to divide the very first 2 terms by it. So what I mean by that is these 2 terms here, not the third one. Okay? And you can, but I think this method's a little simpler. We're going to divide by a half. And what we really mean by that is that we're going to common factor out a half. And since it's negative, we're actually going to common factor out negative a half. So y will be equal to negative 1/2. That kind of comes outside of the brackets. Okay? And now we look at this term here. And it's kind of hard to look at fractions. So think of this like negative 0.5 divided by negative 0.5. Do you know what those would be equal to?
0.
Well, not 0. You're close. They cancel out, but they don't create a 0. They create technically a 1. So they cancel out in this case, which means we're left with the x squared. So that's what's going to be in this bracket. And that's common factoring. Do you recall that at all? Okay. In this version here, we have negative 5 divided by negative 0.5. Okay, that's a negative divided by a negative, which means we're going to have a positive in there. And when you divide by a half or by 0.5, it's the same as technically multiplying by 2. Okay, that's just a little math trick. If you're not sure, just follow on your calculator. You can see, which means this number is actually going to become 10. Okay, so we have 10x. So when we common factor out negative a half, we get x squared plus 10x. And we still have that positive 12 on the outside. Okay, we've done that because this term now becomes really important to us. They give you a little formula that looks like this: b divided by 2 squared. The only thing is this isn't technically b. B was technically the first term we started with, but this is our new b. We take this new b and we plug it in. So the formula then says 10 divided by 2 squared. Okay. 10 divided by 2 will give us 5. And 5 squared is 25. Okay, that number is important to us. Reason being is we're creating what's called a perfect square trinomial. And we won't really build into that because we only kind of need to know this process, but we can talk about that another time. Now this 25, what we're going to be doing with it is we're going to be adding and subtracting it inside this bracket. And the reason we do that is because if you add 1 and minus 1, well, that's 0. So it's like you're actually doing nothing at all, but it's going to help us in the long run transform this. So y equals negative 1/2 x squared plus our 10x, and then plus 25 minus 25. So we do both of those inside the bracket, and then plus 12. Okay. Now, again, the next step. Now that we've done that, we actually want to take out the negative 25. And in order to take the negative 25 out, we have to multiply by the a value. So in this case, we have to multiply by negative 1/2 when it comes outside. Okay, so we'll get y is equal to negative 1/2 x squared plus 10x. 25 stays, so positive 25. But the negative 25 came out, and we multiplied by negative 1/2. And remember, when you multiply, multiplying by negative 1/2 is the same as dividing by 2. And it's a negative divided by a negative, so we know it's going to be a positive term. And half of 25 is, I think, 12.5. So 12.5 in this case. And then we still have the plus 12. So that negative 25 became positive 12.5 on the outside. Is that okay? Mm-hmm. Okay, great. We can simplify our like terms out here. Okay, so I might as well do that in the next step. Just make it easy. We'll leave what's in these brackets here. And this will become 24.5. Great, we've got that. Okay, the very last thing is technically what we're going to do is we're going to factor this. I'm going to tell you really quickly what's going to happen when we factor this. You're going to get x plus 5 and x plus 5. And you can rewrite that as x plus 5 squared. And that's important to vertex form. If you remember, we always write it as 1 bracket squared. This is called a perfect square trinomial. And we created it by doing this long process here. Our goal was to make something that factors that specific way. Instead of going through the factoring, because we've done it this way, there's kind of a shortcut to the factoring. I know that if I square root the first and the last term, so that's square root of x squared, and square root of 25, they'll give me what my factored is. I don't have to actually go through all the products or all the factors. So we get negative a half. And in vertex form, remember, it's a bracket that's squared, and we have plus 24.5 on the outside. We square root the first term. Well, x squared square rooted is just x, so that becomes x. Square root of 25 is 5, so the second term becomes 5. And whatever operation is attached to this 10, that's the operation inside of this. Okay? So our vertex form reads y equals negative a half x plus 5 squared plus 24.5. And that is similar to our, I'm just going to write it in here, the vertex form we're used to seeing, this being a, h, and this is our k. Okay? So kind of a long process. We really got to remember every single step. You don't always have to write every step. I wrote many of them out just so we could see it, but there are a lot of steps to this.